are the important formulae related to inventory model 1b for demand rate non-uniform and replenishment rate infinite. Let us understand some important formulae related to inventory model 1b. Inventory model 1 is under the category of elementary model with deterministic, that is constant demand, as well as shortages are not allowed. For inventory model 1b, demand rate is non-uniform and replenishment rate infinite, because there is instantaneous replenishment, and replenishment means fill in stock. Let us understand some parameters related to this model 1b. Now we know that demand rate is non-uniform. So uniform demand rate is shown by letter R. So instead of uniform demand rate R, total demand D is given. That means in given question, this R is not given, but instead of that total demand D is given, because this demand is deterministic, or we can say constant under the model 1. Q. So what is this Q? Fixed quantity ordered each time when order is placed. So we will understand this model B with the help of this diagram. On the horizontal time there is time, and on vertical line there is the inventory level. So here for this model 1B, Q is fixed. So we have to show the inventory level, that is Q fixed. So we will select one point, and this point will show us the fixed inventory level, that is fixed quantity ordered each time. So whenever the order is placed, this quantity will be fixed. So I will draw here one horizontal line in the form of dash. Then N. So N is the number of orders. So how to calculate the number of orders? That is total demand divided by this fixed quantity, that is ordered. So D by Q, that is equal to N. Then T1. T1 is the time interval between orders 1 and 2. So here we will show the number of orders. So there are N number of orders, 1, 2, 3, 4 and so on up to N. So how to show the time interval T1? So it is in between this order number 1 and 2. So first we will show the order 1. So how to place the order first? So replenishment is instantaneous, that is within no time the stock is filled up to this quantity Q. So this is the first order, so we have to draw here vertical line, because instantaneous replenishment. So this order is filled within no time up to this Q. Now we have to show the time interval T1. So second order is placed here. So we have to join these 2 points. So demand rate, that is here the consumption rate is non-uniform. So how to show that? Because each and every time this slope is not constant. So here is the second order, because at this point there is no inventory, that is zero inventory. So at this point we have to again place the order. So whenever the order is placed, replenishment is instantaneous. So quantity is fixed, that is Q. So again I will draw here one vertical line. So up to this line this quantity fill up. Now again we have to show here the time interval T2, that is time interval between orders 2 and 3, that is T2. So again we have to show here. So this T1 and T2 is different. So in between this first and 2 here is time interval T1. In between 2 and 3 here is time interval T2 and so on. So if we observe, these slopes are different because demand rate is non-uniform, and that's why these slopes are different. So now we have to show Tn. So how to show? That is for n number of orders. Again we will draw here one vertical line, and here is slope. Now this total time period, that is capital T, is equal to T1 plus T2 up to n. So this total time period is known as capital T, that is the time period. So here is the diagram for this inventory model 1B. So if we observe this diagram, slope is different for each and every order placed. Now we will move for the important formula. So what is the first formula? Holding cost for time period T. So holding cost is known as C1. So how to calculate for this whole time period T, what is the total holding cost? That is half multiplied by Q into C1 multiplied by this total time interval, that is T1, T2 plus up to Tn, that is T1 plus T2 up to Tn. So if we observe this, T1 plus T2 up to Tn is known as capital T. So we can write this formula as half Q C1 capital T. Then we will move to the next formula, ordering cost. So C3 is the ordering cost per order. So C3 is for each and every order, that is I will mention here order numbers. So for each and every order, here is order number 1, here is order number 2, 3 and here is order number n. So each and every order C3 is ordering cost per order. So ordering cost, that is C3n, that is n is the number of orders. So we have to multiply with this number of orders. So n we can write in other way, that is capital D by Q, that is C3 D by Q. Now we know that here shortages are not allowed. So C2 is the shortage cost and it is infinite because for model 1 shortages are not allowed. Then third formula, total cost for fixed size Q. So here is, this is the fixed size. So how to calculate the total cost? So this holding cost plus ordering cost is known as total cost. Because shortage cost we will not consider because that is not allowed for model 1. So we will write this addition, that is half Q C1T plus C3 D by Q. Then optimal lot size. So optimal lot size, that is Q to the base O. Or we can also say economic order quantity, or we can also say economic lot size. So Q to the base O is equal to under root of 2 C3 D by T by C1. So here C3 and C1 both costs are considered. Then minimum total cost. So minimum total cost, that is optimal cost C to the base O, and here quantity is fixed. So in bracket we have written Q, which is equal to under root of 2 C1 C3 D by